Welcome, my friends. A system of equations includes two or more equations involving these same variables. We will be dealing with systems of equations where there are both two equations and two variables. Here's an example of a system of linear equations. Usually the two equations are connected by a bracket to indicate that they are part of a system. The equations we will look at will be linear, meaning graphically each equation represents a straight line. There are three types of solutions to a system of linear equations, which are easiest to visualize from their graphs. Case 1 is the most common, which is where the two lines intersect exactly one time. In this case, there is a single solution to the system of linear equations, which is at the intersection of the two lines. We classify this type of system as consistent independent. Case 2 is where the two lines are identical. In this case, any pair of values, x, y, that is on the line is the solution. So we say that there are an infinite number of solutions. We classify this type of system as consistent dependent. Case 3 is when the two lines never intersect, which occurs when the lines are different and parallel. In this case, no pair of values, x, y, satisfies both equations, meaning there is no solution to the system. We classify this type of system as inconsistent. Let's try a few examples solving by graphing. We are given the system of linear equations 2x plus y equals negative 2 and y equals negative 1/3 x plus 3. Subtracting 2x from each side of the first equation, we can rewrite it in slope-intercept form as y equals negative 2x minus 2. We can graph each line by using the y-intercept and slope. The y-intercept of line number 1 is negative 2, and the slope is also negative 2. This means we have the point 0, negative 2 on the graph. Thinking of the slope as negative 2 over 1, we could use the idea of rise over run to go down 2 units and 1 unit to the right to find additional points on the line. But that direction is not very convenient for us, as it would take us off the page. Instead of moving 2 units down and 1 unit to the right, we can use the idea of rise over run in reverse, and go 2 units up and 1 to the left to find additional points on the graph. We will have the points negative 1, 0, negative 2, 2, and negative 3, 4. Next, I can connect the dots to draw the line. The other line has a y-intercept of 3 and a slope of negative 1/3. That means the point 0, 3 is on the graph. We can use the slope of negative 1/3 to plot an additional point using the idea of rise over run. Again, I'm going to go backwards, so instead of going 1 unit down and 3 to the right, I will go 1 unit up and 3 to the left to find an additional point. If you have drawn your graph correctly, you will see that the lines intersect at negative 3, 4. This is a consistent, independent system of equations, meaning there is only one solution, and that solution is negative 3, 4. Let's try another example. We have x minus 4y is equal to negative 4, and y equals 1/4 x plus 1. Let's solve the first equation for y. Subtracting x from each side, we have negative 4y is equal to negative x minus 4. Dividing each term by negative 4, we have y is equal to 1/4 x plus 1. Notice that both of our equations are exactly the same. You probably know what that means, but let's go ahead and graph anyways. Our y-intercept is 1, so we have the point 0, 1 on the graph. Then we can use the slope of 1/4 to graph an additional point, 1 unit down and 4 to the left, using the idea of rise over run in reverse. We have technically graphed both lines since they are the same. Our answer is that this is a consistent dependent system, meaning there is an infinite number of solutions, which include any point on the line y equals 1/4 x plus 1. Okay, one final example. We have y equals 5 halves x minus 3, and 2/5 y is equal to x minus 8 over 5. Let's solve the second equation for y. Multiplying each side by 5 over 2, which is the reciprocal of 2 over 5, will cancel the coefficient of 2/5 on y. On the right-hand side, we need to distribute the 5 halves to both terms. We are left with y is equal to 5 halves x minus 40 over 10. Simplifying 40 over 10 to 4, we have y is equal to 5 halves x minus 4. The first line has a y-intercept of negative 3, meaning the point 0, negative 3 is on the graph. The slope is 5 halves, so we can move 5 units up and 2 units to the right to plot an additional point on the graph. We can connect the dots to draw our line. The second line has a y-intercept of negative 4, meaning the point 0, negative 4 is on the line. Then we can use the slope of 5 halves to move 5 units up and 2 units to the right to plot an additional point. We can connect the dots to draw our line. Notice that the two lines are parallel, which you may have been able to predict as their slopes are the same. This means we have an inconsistent system that has no solution. No ordered pair will make this system true. Alright, my friends, that completes our video discussing how to solve systems of linear equations by graphing.